I've made a good amount of Dactyl Manuforms. I've posted some videos of them on my channel and had a couple comments asking, well, how do you make one? So I thought I'd do a full, longer guide on how to actually make them, take some recordings of the different parts of soldering, and etc. So I'm going to go over right now the parts that you'll need to make your own Dactyl Manuform, some tips for the soldering with some videos, and some help on the programming side. Starting with the things that you'll need. I've got some things behind me, so let me grab some of those. The first thing that you're going to need is a soldering iron. This is my soldering iron. It's a TS80P. I find this thing to be extremely nice. It is plugged in by USB-C. It is low enough power draw that I can actually run off of a battery bank, and it comes with a nice needle tip. I find all of these things very useful for some of the more intricate areas of soldering, especially because overall it is fairly small. The next thing you'll need is some form of desoldering equipment. It's technically not necessary, but you're going to make mistakes. It's not an easy thing to do. So things like desoldering wick, a desoldering pump, like a hand desoldering pump, or in my case, I believe this is a Hakko FR301, better known as the glasses gun, which is capable of heating up and sucking. I find this to be very useful, especially for the Dactyl Manuforms, because some things are a little hard to reach with a pump, but even so, it can get complicated. The next thing that you'll need is solder. I use what Amazon recommended me, which is this SaneSmart 0.8 millimeter wire with a flux core. I know not too much about solder. I know that the standard that a lot of people use is Kester solder, but Kester solder is expensive, especially if you don't expect to do a lot of soldering. Maybe a smaller spool is better. The most important thing is to get one with a flux core. You technically don't need it, but it makes it a lot easier to do some of the soldering inside the case at a nasty spot. The next thing that I recommend is having a good fan with a carbon filter on it, or a good mask and goggles. I personally prefer to use a mask and goggles because I don't have much space on my desk for a good fan, but you can do either. Just with the mask N95. You want to not be breathing in lead. A good method of cutting wires is nice. This is some just basic flush cutters that I got off Amazon. Fantastic. They cut well. It's the second pair I've had, not of these ones in particular. Good reviews by a good one. Wire strippers. You're not going to get anywhere without these. Well, you technically could, but it would be an absolute pain. Get yourself a cheap pair. This is a set I've had for a very long time. I honestly don't have any links to any good ones because I haven't used them. But just make sure that you're getting one that has the size of hole that you need for the size of wire that you're getting. Now, for wire, I use this 30 gauge silicone braided wire. And the reason I use the silicone wire, here, let me get a better color, is because it's flexible. The flexibility is really useful for when you solder Dactyl Manuforms the way I do. Technically, some people might find it a lot easier to use a solid core wire. That's just not the case for me. This kind of type of wire is covered by my wire strippers, so all good. I got this off Amazon. It's lasted me through a good amount of boards. Very useful. Finally, I'd recommend having a set of tweezers on hand. I don't know where they got these tweezers either. Very useful just for positioning small things inside the case. It can be hard at times. It's nice to have. Now to get into parts for actually assembling the board. You're going to need a case, obviously. So this is it's a Dactyl Manuform 5x6. It's been very heavily column. It's got weird spacing. It's not at all normal. We'll get into why that's can be a bit of a problem later on. I'm not very good at generating case files myself, or else I would go through the details of doing that. I'm not. You can find other guides online that probably help with that, or you can spend money and go and ask someone else to print it for you. These will typically come with not drive sleds, microcontroller sleds, so that you can stick in the microcontroller and auxiliary or TRS connector, and will have a bottom that you can screw in. I use Amoeba PCBs. Amoeba PCBs are single switch PCBs that come in sets of 30. So these snap into little pieces. Not particularly easy, and I do recommend watching out because they are fiberglass and you can get yourself fiberglass cuts which itch. Little single switches. Very useful for this type of board because they've got a lot of different holes on them to make sure that you can connect the right things to the right things. It also allows you to use some SMD circuit components, which I'll get into in a moment, and overall keeps everything clean. You can get these off of Keebio. This is where I get almost all of the parts here. Next is the diodes. So you can get these off of Keebio as well. I use the SMD diodes, which you can kind of see there. They're tiny. They attach to the Amoeba PCBs. You can solder them on pretty easily with maybe some solder paste and a soldering iron. You can do hot air soldering if you're comfortable with that. Probably don't need to be here if you can hot air solder. The diode is super important. You can't forget it. If you're not using Amoeba PCBs or if you're not comfortable doing SMD components, you can get through-hole ones. The Amoeba PCBs support through-hole diodes, so just connect them up and solder away. I do recommend soldering while they're all together. It's a lot harder to do when they're individual and already broken apart. Next is the microcontroller. I personally, the default one I go to is the Elite C. The Elite C is a USB Type-C microcontroller, actually designed in Canada. The Elite C is a version of the Arduino Pro Micro that has some extra pins on the end. That allows you to add extra rows and extra columns that the Pro Micro wouldn't be able to. For a standard 5x6, you're able to get away with a Pro Micro, but an Elite C is a lot better if you're doing anything larger. Personally, I prefer a 5x7 Dactyl Manuform, which requires an Elite C. Or technically it doesn't, but it's a lot easier if you do. Now, the next thing to get into is the TRS jacks. This is the method that you're going to connect the two halves of the board together with. They're from Keebio. They look kind of like this. They've got 4 connections on them. You will only end up using the side with 3 connections on it. The 4th connection goes all the way up the thing. Just don't use it. These need to be TRS, or else you will not have enough wires to be able to connect it. Your cable for the board also needs to be a TRS cable. Make sure when you buy the cable that it is a TRS cable, or else it won't work. The final thing that it would be part of a Keebio order that is optional is a reset button. We'll get into later why a reset button is only optional in my case, in my opinion. But the first reason, and smaller, is that the Elite C actually has a reset button built into it. It's really small, but it is there. So if you really need to do a hard reset, you can, but there are ways in firmware to avoid ever having to do that. Finally, you'll need M3 screws and M3 threaded inserts. Oh, can't really see well through this bag. I've put a link to them in the description. I get them off of Amazon. It depends on what type of bottom you have to know how many of them you actually need and what length of screw you need. It might be worth buying a larger box that has multiple different lengths of the screws. But just make sure they're M3. That is essentially every Dactyl Manuform I've seen uses M3. So just keep it easy. Grab M3. That's all I can think you really need. So now I'm going to go over to my soldering area. I've got some recording to do and show you how to do some of this stuff. So I edited in audio after the fact, as you can probably tell. The audio off my camera and the video quality off my camera is clearly pretty bad. So here you can see I'm starting with soldering the rows. I take a single amoeba PCB, take a longer piece of wire, strip it a bit, and then trim it to where I think it's going to reach. I will then strip the other side of the wire and feed it underneath the bottom and solder away. I will get a more close-up shot of this later in the video. Solder a little bit, and then I will attach it to the case and make sure it fits. This is kind of hard to see depending on where I test it on the case. But you can see, yep, it fits on that and it reaches, so we're all good. Now it's time to head back and just do the rest of them. So continuing with stripping and soldering and stripping and soldering, testing every step of the way. Now you can see that I have finished the row. It's all good. And we're just going to test fit one last time, make sure everything's good, testing every single different row. And then one important thing I like to do is I like to trim off the tips of the wire, because if you don't, sometimes they can interfere with the switch, making it a little bit hard to place them in the end. It's just a little bit of extra stuff. It's just nice to do. Now we've gotten a lot closer up, and you can see that I've finished 2 of the rows. So now that I've done 2 rows, I like to link them together as columns. So I'm a little bit of an idiot here, have it off screen, because, well, this is my first time really recording something this kind of close up and just in general. So you can see here it's much of the same process with the rows, where it is strip the wire, solder the wire, and then cut the wire at approximately the length that I think it's going to be. You can test by just like first measuring a little bit in the case, measuring your wire out. If you really want to not make mistakes, that's probably the best way to do it. I just try to get a good balance of speed and actual usability. So I've placed the wires, all the ones that I should need to solder, and then a bit of soldering. Solder each part, and then after I am done, of course, I will make sure things fit. With this row, the spacing between the keys is almost perfectly consistent, so I won't be testing too much through the rest of this. One important part to note about what's going on here is you can see that the what I would call the front of the PCBs, the side that would face you when you are soldering them to the switches, is actually facing down right now. This is done so that the wiring doesn't interfere with the case and comes up instead of rather goes down. It's pretty important that you do this. I don't think it'll really fit with most switches if you try to have the wires on the same side of the PCB as the switches are. One thing which I'm showcasing here is that you need to pay special attention to the thumb cluster. As you can see off on the left, the whole matrix is done. Fairly simple, just a lot of repeating the last thing. But the thumb cluster is a little bit different. Those final 4 keys, you need to make sure that you match the way that you've placed the switches into the holes with how you're laying out the Amoeba PCBs. It's easy when you're flipping things around to get to the right side to solder on and everything like that. You make a mistake. It's just important. You want to double check, triple check, make sure you're not making these mistakes so you don't have to desolder, because desoldering is a massive pain. So you can see here, I am fitting those switches in, and you can see that those switches do reach even though they Amoeba PCBs are rotated 180 degrees from each other. All right, so here I'm pointing out some more important things with the thumb cluster. The thumb cluster is fairly hard to connect with columns. You want to be very careful. You want to match them up very well. And you're going to need some long wires for some of them. Keep that in mind. Make sure you measure with the case so you don't screw up. You also want to make sure that with all the flipping and stuff, you put it on the right side of the matrix, or else you can really get screwed up when you go back to put it in the case. So here you're going to see me do some hand signals that would relate to what I was talking to in the video. So one of the things you need to do now is prepare the wires for connecting it to the microcontroller. I'm showing off here the microcontroller, and I've shown that you do need very long lengths of wire. And this is no spot to be a hero and minimize the amount of wire you use just to make sure that you're saving wire. You need long wire. It is an absolute pain in the butt if you try to do this with shorter wire. Basically, you end up having to solder the microcontroller while it's dangling in midair, and no one really wants to do that. So I measure out with the case, making sure that I have a very long piece, and then make sure that I connect to the right rows. I pointed out the rows there, and the right columns. I typically use different colors for the columns and rows. Now with the column and row wires all finally connected, it's time to solder in the switches. So I take a PCB, I choose where to start. Here I'm starting with this one. Hold it down with a finger and get my wire ready, then my iron ready. Use my iron to partially hold down the PCB, and then just apply solder to it as you would a normal PCB. Then I'll hold back down the PCB to make sure it doesn't move, and then move to the other one once the solder joint is clear and solid. Then we're done, and now it's just time to repeat that for a lot more switches. Now here's a fun problem with my case. Those PCBs don't fit in there because of the steepness. I'll need to make some weird hacks to get this to work. So do note that this problem is something unique to this kind of board that has a messed up thumb cluster. Here I am soldering a bit of solder to the leads of the switches. This way I can add some wires to them, some short wires, and then attach those wires to the single switch PCBs to connect the circuit without having to do anything extra like soldering through hole diodes directly to the legs, which can be a little painful. So now the switch is back in the case, and you can see that I've actually fed the wires through the holes that are normally meant for the extra 2 legs on the switches, the ones that are meant for stabilizing the switch. Now I'm just feeding the wires, looping them back into the spots where they're supposed to go on the PCB, and then I will apply solder to those wires, and it'll be all connected and work just fine. This is one of the definite reasons you want tweezers. It makes stuff like this a lot easier. All right, let's take a step back from soldering and go look at some firmware things so that we can make sure our next step with soldering is done correctly. If you go to the QMK repository on GitHub, or you download the firmware through QMK MySys, which you will install through the instructions found on the QMK website, you will be greeted with this massive set of folders. You'll want to go into keyboards and then scroll down a considerable amount till you get to H. And then in here, you'll find handwired. Inside handwired, we're going to want to go into Dactyl Manuform. And now we're greeted with a bunch of different sizing options. I'm making a 5x6 right now, so I'm going to use the 5x6, the first of the 3. Now in here, there are a bunch of different files. For knowing what pins to connect on your Elite C or whatever microcontroller you're using, you're going to need to go into the config.h file here. So you can see here, there are some important pins called out. You can see here we've got the matrix column pins and the matrix row pins. These are where you're going to connect your rows and columns. For rows, you'd want to connect row 1, so the top row, to F6, the second row to F7, and so on and so forth. You can change these numbers to different numbers and letters to different pins on the Pro Micro, should you desire. The columns are also important. It's the same kind of thing, but it actually flips in the middle of the keyboard. On the right hand, you're going to want to follow the order that you're given here, going from the inside of the board to the outside. So from where the microcontroller is to the edge of the keyboard when you'd flip it over. So in this case, so that would mean what I'd consider column 1 is D4, C6, and so forth. But on the left hand, you're going to want to flip it. So for the spot closest to the inside, it'll be B5. So column 1 would be B5 and following backwards through the order. Worst case, you'll have to desolder some pins off of the microcontroller, but hopefully that's enough of an explanation to get through that. In some of the repositories, it'll also be called out what your communication pin is for the between the two halves. This is where you'll attach one pin of the TRRS connector. By default, it is D0 for the Elite C. I'm not certain for other microcontrollers. The Pro Micro will be also D0. But that's another important thing to write down, because those are important for when we go back to the soldering station and start soldering the microcontroller to the columns and rows. Now, before you solder the microcontroller up to the rows and columns, you'll probably want to solder it to the TRS jack. So you can see here I've got 3 different wires that I know are going to be long enough, and I have pre-tinned the ends of the auxiliary TRS connector. The focus is a little off, so it's hard to see that that's there, but it is. So now what I'm going to do is I'm going to lay them there, heat up the solder that is already on the pad, and just get a good connection. It's not the greatest technique, but it does the job fairly well. In this sped up section, I'll go over a little bit more here. The cables I'm using are intentional. I'm using green for data, black for ground, and red for power. The black ground pin is always connected to the first pin on my TRS jack. This is so that just in case people are plugging it in and out while it's being used, it doesn't super short everything. So now you can see here, I'm just attaching the power and furthermore the rest of them to the Elite C after confirming that yes, it's the right direction and everything's going to fit and line back up and connect without too much issue. Now we have the last step on this god-awful camera, connecting the MCU pins. So you can see here I've flipped the board up in such a way that it makes it a little bit easier to connect the pins. Then I'm just going to make sure that I've got the right one. I've got a sheet off on the side that I'm using just to make sure that I get it right every time. Then it's more of the same. Strip wire, put wire into right spot, and solder wire. The last thing to get into is the key map and QMK. QMK is a very complicated and large repository and set of firmware that can do pretty much everything you want it to. I can't go over everything in a single video. There are many videos on it already, but a couple hints I will give you is that the QMK beta docs are typically a bit better than the standard ones. There are some exceptions that I know about, but more often than not, you're better to go to the beta ones. And don't hesitate to go ask questions on the QMK Discord. They're really useful and really helpful over there. I've definitely asked my fair share of questions, especially when it comes to the more exotic things like screens in your keyboards. So let's get into what you need to do to actually program your Dactyl Manuform. So we're going to want to go back to that Dactyl Manuform folder inside the QMK firmware. This is where we last left off in that folder. You'll then want to go into key maps and default, or you can make your own folder and copy the contents of another folder. And you'll see keymap.c and config.h. To edit your key map, you'll edit keymap.c. It'll have a basic layout that you can use the information from the QMK docs to fill out your own keys wherever you want. One recommendation I will make is that you, at somewhere that is accessible on both hands, add a reset key. This allows you to not have to open up the Dactyl Manuform and press a physical button inside every time you want to reprogram it. You can just press a key combination and have it do that reset. Before you program the Dactyl Manuform, though, it's important to set something in the config.h. I've played around with a lot of different options here, and quite frankly, this is the one I find to be the easiest. You'll have two things here, one of which will be commented out, defining master left or defining master right. This is which side of the keyboard you are currently programming. You're going to have to program each side separately. So, for right now, I'm going to compile a master left version of the firmware, because that's the one I need to program the Elite C I have in my hand right now. So I defined master left, commented out master right, and saved. Now we'll open up QMK MySys, and we'll type our command string to compile the thing that we have just worked on, the firmware we've just worked on. So the tutorial for how to write all of this is on the QMK docs websites. It boils down to QMK space compile and then space dash KB, and you write the path to the keyboard. So from the keyboard's file. So this one is in handwired Dactyl Manuform 5x6, and then space and then dash KM for the key map, and then you write whatever the name of that folder is. We've used the default folder. So it'll run this, and this will take a while. It's not a particularly fast operation. It does a lot of compiling. I don't know, for some reason it does seem to hang here for a little while. Let it go. After it finishes, you'll want to open up QMK Toolbox, another thing provided by QMK. There are other ways of doing this, but QMK Toolbox makes it easier. You'll then open up and find the firmware you want to program. So as you can see here, we're just about finished compiling. It's going through all of the different files, bundling them together, making sure everything's good. And it's done. Now we're going to open this up again, grab that one we just compiled, and then press OK. Now, you need to plug in the Elite C Pro Micro or whatever it is. You'll see here if it's ready to program that a yellow line will pop up. If it's not, you might need to press the reset button on the microcontroller or bridge the reset pin with ground. You will then just, since you've got this selected and something is ready to be programmed, you just press flash, wait a couple seconds, and it's programmed. So now if you already have this ready and in your keyboard, you can press the keys and start testing. Or if you're like me and have it out in open air, you can start bridging connections to make sure that your microcontroller is just working. And that's pretty much the end of programming. This covers the basics of it. You can find a lot better tutorials on how to do such things on the QMK Docs websites and from many other people. The important thing to take away from this video is that you need to change between master left and master right when you're programming each keyboard. So right now I would have to go and get the other Elite C and comment this out and uncomment this line and program in the other one. That way they will both work when connected together. And that's pretty much it with all of that information and a bit of information from outside sources looking at the QMK docs. You're able to make your own Dactyl Manuform. Now, I will say this, as I iterated many times, it's hard. It's a lot of work, especially on your first one. It's going to take a decent bit of time. There's no shame in getting someone else to do it if you really want a Dactyl Manuform. But if you're up to the task, do it. It's a lot of fun. It's a good amount of learning. It's just hard. I'm genuinely happy I learned how to do it, and it's really been beneficial to me overall, so I definitely would recommend other people do. But go in knowing it's hard. You're going to scrub a bit, and you might burn yourself.